Okay, now that we've completed the setup for DynaConn, I go ahead and show how to use the tool. So, as I mentioned, we completed configuring the setup for gift mode, and so now I can select various components, and you can see that we can select between different components, and these are our IC independent components from gift, and we can change between our different subjects. And what we're seeing here is this top window is the TC, the time course for the components. The blue one is component 3, the red one is component 5, and it lays them across each other. And then we can see that the dynamic functional connectivity, the DFC, is here in blue. This is the correlation between these two time courses, but it's the windowed correlation between the two time courses, which is a dynamic functional connectivity. The window size here is 32. We can change the window size and see the effect of a different window size. We can also change the step size and see what effect it has. And you can see that it gives you the average component correlation is 0.636, and also we see this red file this is the expected value from the EV file, the expected value file that we loaded before. And of course we can get more information on all this by clicking on Help and User Manual. That'll pop up the user manual for this tool. Now for these particular components that we selected, we can choose to look at the components. So if we say show regions, what that'll do is it's going to pop up a display window that displays in axial form component 3 and component 7, which are the components that we selected for the mean file. What we also have here is a z-score cutoff, because the values that are shown here are the extremities, the positive and negative extremities of the z-score. The maximum z-score for this component is 14, and the maximum for this component 7 is 15.2. But if we can increase the z-score cutoff, which means we see even the further extremities of the z-score data. So if we were to increase this, you can kind of see some of these small points kind of go away, because we're getting rid of some we're getting rid of more of the centered data. We also have here is this is the regions that correspond to these components. So in this case, component 3, this highlighted data here, it corresponds to this anatomical region, and the anatomical regions come from the brain atlas that we loaded. And the way that this is computed is the region defined by that brain atlas is compared to this data, and the more area of that anatomical region that is covered, the higher the coverage score here, the higher cover percentage here is listed. And so it sorts these by highest covered percentage. It also shows a frequency in this case, because the brain atlas that we're using here is a probability map, meaning that the way it usually works is that the closer to the center of a region you get, the higher probability that you're in that region. So voxels that are closer to the center of that region have a higher score versus voxels that are near the outside of the region. So you can have a region that has a lot of coverage, like in this case about 67% coverage, but the number of voxels that are in there are only about 47% of them. So that's the frequency. And so you can also see the z-score cutoff affects the coverage score as well. The higher I make the z-score, meaning the less data that can cover a anatomical region, it corresponds to a lower coverage score. So if we also want to look at more than just these two components, we can use this tool called Component Region Matrix. Okay, so this is the component matrix display, and the way this works is on the x-axis we have 190 network combinations, or 190 IC combinations, and that's because I have 20 ICs, and so 2 of 20 ICs gives us 190 possible combinations. And then on the y-axis is our subjects, and as well as this is also the mean value, because GIFT outputs a mean as well. And so above this, so this orange line divides the groups. So above the orange line is group 1, and below the orange line is group 2. And I had put the mean in group 2, but it really doesn't matter. So each one of these values, each one of these colored bars, is the average DFC result for a particular component combination and for a particular subject. The way that these are ordered is group 1, the average for each component combination of group 1 is taken and then sorted based on that average. And then that sorting order is applied to all of the subjects of group 2. There's a couple of other functions here. You can change the color map of the data to, I guess it's rainbow, copper, black and white, and this original color map, which is based on Cynthia Brewer's Color Brewer. And then you can also select the actual data point from this map. I'm probably not going to do that because I happen to know that causes my screen recording software to stop recording, but trust me, it does work. You can try it on your own. But I do want to show you can zoom in, to use a magnifier and zoom in to a particular area, and then you can use that function to click on a result, one of these results, and that will update both the main viewer and the component viewer to that new component to component combination and to that new subject. The other part of this I wanted to show is our data output functions. So there's 5 of these data output functions, and what they do is they'll export all of the DFC data into a mat file, which is it'll just be a matrix of our DFC results. The point of that is to use this DFC data for external classification, using those DFC values as possible features in a classification exercise. And there's more information on all of those output functions in the user manual. Now I'm going to go ahead and go onto region mode. So in region mode, again, we previously configured a setup for region mode, so I'm just going to load that up. And last time when we loaded the region mode, it precompiled all of our region averages, so now I can just simply click on another region and it updates my component display, which was already open, and it updates the main window as well. And if you noticed, I guess I should go back to that, our component display, in this case it doesn't mean as much because by definition we already know where the data will be for a particular region, because we're selecting the regions, and these regions are defined by the brain atlas that we selected. But it is a useful tool for understanding where a particular brain region is in the brain. But we can use the region matrix in this case. Now if you'll notice, there's a lot more combinations on the x-axis because we have a lot more regions, so we have a lot more region-to-region combinations. And again, you can zoom in, select a particular data point, and that'll update the main window and the component display with the new regions. And again, similar to GIFT mode, in this top window we're looking at the TCs of these particular anatomical brain regions. So this blue one is the pre-central left brain region average across time. And so there was 384 data points. So this is the average value for that brain region across these 384 data points. And then the blue is the correlation, the sliding time window correlation between these two regions set by our window size and our step size and for our particular subject. And again, we have this expected value result as well from similar to before, where we take the times from our EV file where a subject is given a task, and we insert a HRF, a hemodynamic response function, into that waveform at those times, and that builds this waveform. It's useful for comparing against our DFC result to see if our DFC values are task modulated. So now I'm going to move on to group mode. Now group mode uses the setup from gift mode because it's going to be looking at DFC results from components. And actually, I guess I should correct myself and say it's actually looking at the DFNC results because which is a dynamic functional network connectivity results, because we're looking at brain networks and not just anatomical brain regions or other regions of interest. So what this is we can select our groups. Now I only have two groups, group 1 and group 2, and then I select the components that I want to compare. I'm selecting component 1 and component 3, and what this is the like if I choose the blue one, this blue is the average DFNC result for all of the subjects in group 1, and the red is the average DFNC result for all of the subjects in group 2. And then we're doing a Mann-Whitney U-test on these two different results and plotting the p-value of that test. And then the red is telling us whether or not the null hypothesis is rejected at 5%, where 1 would indicate a rejection of the null hypothesis. So in this case, we never reject the null hypothesis. You can use the region, the component display again, and it's going to display those two components, the mean value, since we're using multiple subjects in this analysis. And you can use the matrix display. Now, in the matrix display for group mode, it's a little different, and it's instead of subjects, we have our group-to-group combination. So, and I only have one group-to-group combination, which is group 1 to group 2, and it's displaying the p-values for each of the 190 component combinations. So in this case, I would probably want to look at the values for the lowest p-values. I would again select on the plotting of this value and let it update my main window to see if this lowest p-value rejects a null hypothesis. And that is about it. I guess lastly I'll say one thing you didn't see is that whenever I select the matrix display, it will ask if you want to let it calculate all of the DFC results, and depending on how many subjects and how many combinations you have, it could take a while, but I had already done that ahead of time, and so whenever I loaded this setup, it stored those pre-calculated DFNC results, so it just pops right up. Alright, thank you very much for listening.